Okay, here we go. I gave you guys some new notes. These you can add to your previous notes, but the deal is that I looked at the lesson that we covered the past few years, and I'm completely dissatisfied with the results. So if I would go up to students in calculus right now and say, what is the domain of this function? I would say probably 2/3 of them would exhibit some anxiety. They'd be like, I don't know, I never really understood domain. So I'm not going to say that I'm going to make this easy, but hopefully it's better than it has been in previous years. And I just want you to know that there's some things in algebra that I can kind of give you a process that you follow step by step. And there's other things you kind of just got to think about it. And you're going to have to think deep. So hopefully this will work out. Number one, do you know what the definition of a function is? Because you're going to have to know that for your test. Very good. A relation in which every element of the domain corresponds to exactly one element of the range. So it's very important in your definition that you include domain and range. Domain, for our sake, is going to be the x values, and the range will be the y values. We may think of the domain as the input, and the range as the output. Yes. This test will not be till after your final exam. You have a final exam either Tuesday or Wednesday of next week, and I do not yet know which day that is. I do not make the decision. No, I will give you the study guide. I told you I'd give it today. I ended up subbing 7th hour yesterday, so I was not able to run the copies, but I am running them 7th hour today. I had a few students ask if they could get help 7th hour. I said no. And so I'm going to instead, it's my prep time. I'm going to use my prep time. I need my prep time. Now, that said, Natalie sometimes comes and works in my room. If you want to work in my room, that's fine. But somebody wanted me to reteach them the last 3 lessons we've done, and that isn't going to work. Okay. All right. So if you want to stop by my room at the end of the day, I will have study guides for final exam for you. Okay, it says identify the domain and range of the following. This is functions. They don't have to be functions because number 4 isn't, so my bad. Should say probably relations. And express the domain and range in interval form as well as an inequality. We're going to skip the inequality because we're going to run out of time today. We're going to go straight with interval form. So here's what we look at when we see domain. You notice I have this vertical line right here. I'm going to show you what that is in a second. But if I look at graph number 1, if I were to plug in a value of -6, is there a corresponding output? No, there's not. How about if I plug in -5, is there an output? How about if I plug in -3? There is. How about 0? How about 2? So what I like to do is this. I drag this vertical line across. And when I start to pick up values, those are the ones I write down. So it looks like I go from -4 to -1, and from 1 to 4. But I don't include which value. So therefore, I write it as -4 to -1, union with 1 to 4. Whoops, sorry. Okay, now for the range, I'll drag a horizontal line. Do you have any outputs down here? Now, here's the difference. These are very specific values. So I have the value of 2, and I have the value of 5. And to show that it's just those values and not the ones in between, I use what we call roster notation. It takes practice. You got to practice. Yep. 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 There's a class you take in college for math teachers. You learn how to write those. Okay. Now, let's be clear, folks, that if the graph looked like this, okay, then it would be from 2 to 5 with brackets, okay? Because it would be saying it would include every value in between 2 and 5, whereas this is specifically only the values 2 and 5. So like you would list off a roster on a basketball team with specific players, that's what we're doing here as well. All right, let's move along. Letter number 2, okay? I grab that vertical line, I drag it across. Am I going to have values out here? Yep, here, here, here. No, it looks like I run out at 1. So I go from negative infinity to 1. And as I look at the range, we'll cross here eventually. Yep. So I go from negative infinity to 4. How about this? Yeah. And so you could write negative infinity to positive infinity, or if you'd prefer, you could say all real numbers. Should really put all in front of it. And then this one, same thing, all real numbers. So again, you could do negative infinity to infinity and all reals. Okay. So you don't have to write both. You could write one or the other. If you'd like to write an inequality instead for this, you could say y is going to be less than or equal to 4, or x is going to be less than or equal to 1. So you could do an inequality as well. There's different ways to express it. We've already tested on that stuff. You guys know the difference. All right, what's the domain here? What do I start with? Negative 5 to what? Negative 1. And the range? Very good. Because it's sitting on negative 5 and sitting on 1. Okay. How about this one? Negative 2 to 2. Range? And how about this guy right here? We've got domain is going to be infinity to infinity. But what's the range? It's negative 1. Now, some people might they might have a mistake here. Instead of writing negative 1, what do you think they would possibly write instead? Negative 3. But that's the x value. We want the y value. Okay, flip it over. All right. Students have always understood how to find domain when they look at a graph. The question is, what if the graph is taken away from you? Okay, so very good. So Gigi says, look at your calculator graph. But we should be able to look at something and understand without even graphing it exactly what the domain is. And I'll give you an example. When you're looking at domain, you're looking at the available inputs. So you're trying to think about, is there anything that you can't plug into x squared for x and get out a value? Like, can you plug in negative numbers? Can you plug in positive numbers? Can you plug in 0? Yeah, and if you think of the graph, it looks like this, and so you'd say that the domain is all real numbers. We'll forget about the range for this part. Okay, we're going to focus on domain right now. But then you look at the next one, number 8. It says f of x is 2x divided by x minus 3. And all of a sudden, you have no idea what it looks like. So you start thinking about numbers you could plug in. Give me a number, Alex, whatever you want. 3. So Alex plugs in 3. He gets 2 times 3 divided by 3 minus 3. So 6 over 0. Can you do 6 divided by 0? So it looks like 3 is not one of the numbers that you can plug in. Give me another number. 4. You would get 8 divided by 1, which is 8. So it looks like 4 is a number that you can plug in. There's only one number you can't plug in this situation. What do you think it is? 3. Because why can't you plug in 3? you'd be dividing by 0. So the domain is x not equal to 3. Now, if you would like to write it in interval notation, negative infinity to 3, parenthesis, union with 3 to infinity. I don't care. Now, I'm going to show you the graph. The graph has what we call asymptotes. Asymptote is a Greek word, and it means a line that the graph approaches but never touches. And the graph looks like this. And if you look at that graph, does it make sense? By looking at the graph, you can see that you can't plug in 3. Yeah. Includes everything but 3. Okay. Let's look at the next one. Square root of x plus 4. Again, you're like, I don't know what it looks like. Well, think of a number that you can plug in, and think of a number that you can't plug in. I can plug in negative 4, because negative 4 plus 4 is, and the square root of 0 is, so negative 4 works. 5 plus 4 is 9, square root of 9 is 3. 12, can I plug in 1? Yeah, you get the square root of 5. You may not like the square root of 5, but you get an output. What's the number that if you plug in, you don't get an output? Negative 5, because you would get the square root of negative 1, which is imaginary. And we can't plot imaginary numbers on a real axis. That doesn't work. So therefore, if you think about it, x has to be greater than or equal to negative 4. Any values that are less than negative 4 won't work, but any values bigger than negative 4 will work. Now, really what we did is we said x plus 4, that thing underneath the square root, it has to be positive or 0. It can't be negative. So what we thought about is setting up that inequality and subtracting 4, so x is greater than or equal to negative 4. So our interval would be from negative 4 to infinity, and that is our domain. The graph actually looks like this. It actually starts at a value negative 4 on the x-axis, and it heads off in that direction. There is nothing behind it. Okay? So let's consider different types of functions. Spelled functions wrong. And domain restrictions. Okay? So, for example, there's polynomials without restrictions, like y equals x squared. Plug in whatever you want, and you're going to get an output. Y equals x minus 1 quantity cubed. Plug in anything, you're going to get an output. Y equals x to the 4th minus x squared all over 6. You might be like, well, that's rational, Mr. Gantz, because you're dividing by something. Well, isn't this just really 1 over 6 x to the 4th minus 1 over 6 x squared? I mean, it's the same thing, isn't it? So it's just a polynomial, and you plug in whatever you want, you're going to get an output. There's really no restrictions on those type of things. Well, when you think of rational functions, there are rational functions that cause problems. So like y equals 1 over x minus 2. What's the value you couldn't plug in there? Or suppose you had y is equal to 1 over x squared minus 1. Or 0 is fine. You plug in 0, you get negative 1. But if you plug in 1 or negative 1, you'll get an undefined result. What about this? Y equals 1 over x squared plus 5x plus 6. Negative 2 and negative 3. Yep, those don't work. Now, I'm going to give you an example of one that doesn't have any restrictions on the domain. Y equals 1 over x squared plus 1. Remember, we got to be careful where the bottom would be equal to 0, right? Can x squared plus 1 ever be equal to 0? No. If you think about the graph of x squared plus 1, it's a parabola shifted up. Does that ever cross the x-axis? No, it doesn't. So you don't have anything you have to worry about there. Okay? If you have y equals 2x over 3. Again, people say, well, that's a rational function because you got something in the denominator. Well, if you think of it as a rational function, still the denominator cannot be equal to 0 ever. You're fine. Or if we have, say, y is equal to 3 over x to the 4th plus 2. X to the 4th has to be an even number, right? If you take something to the 4th power, it's going to be even, and add 2 to it. I'm sorry, not just even, but positive. Then you add 2 to it, it's going to be positive, so there's no way that can be equal to 0. Let's think about the radicals. Y equals the square root of x plus 3. What's the smallest value you could, or what's the least value you can plug in for x? Negative 3, right? Yeah, so there's some restrictions there. What's the number you couldn't plug in? Negative 4, okay? Y equals, if we think about the 4th root of x, okay? Now the 4th root of something, what's the 4th root of 16? 2. What's the 4th root of negative 16? Interesting. You guys have said 2i. So if I take 2i times 2i times 2i times 2i, you guys are going to say I get 16. Well, 2i times 2i is negative 4, right? And 2i times 2i is negative 4, so you get 16. And I said, what's the 4th root of negative 16? So unfortunately, you had a good guess, but you're not quite there. The fact is, you don't know what it is. I'll have to teach you someday what it is. It's kind of complicated to think about, but you can't take the 4th root of a negative number, and so that becomes problematic for us. But there are things that you can take roots of. For example, the cubed root of x. What is the cubed root of negative 8? Negative 2. You can take the cubed root of negatives, right? Because a negative times a negative times a negative is a negative, okay? Now, I'm going to make you angry here, but I'm going to do the square root. I'm going to put a square root down here without restrictions. And inside, I'm going to put x squared plus 1. Well, can x squared plus 1 ever be negative? It's always positive. So even though it's a square root, this is going to be okay. All right? So let's try some examples now that we've sorted them through and clarify any of our confusion. Some of these are going to be challenging, some are going to be super easy. Square root. You can't take the square root of a... So we're going to say that x plus 2 must be greater than or equal to 0. Because you can't take the square root of a negative. Subtract the 2. X is greater or equal to negative 2. So my domain is from negative 2 to infinity. X squared plus 3. That's just a regular, ordinary polynomial, right? Domain? There's no restrictions. You can't come... If you say for a second, well, x can't be negative 3. Well, try plugging it in. Negative 3 squared is 9, plus 3 is 12. You get an output. You can plug in anything you want. Uh-oh, rational function. Can't divide by 0. So GG, x can't be 12. I have a radical, a cubed root. Can you take the cubed root of positives? Cubed root of negatives? Are there any issues with cubed roots? Thirteen is a rational function. Can't divide by... What would give you 0 in the denominator? So x can't be 0 or 5. Fourth root. Can't take the 4th root of a negative. So 7 minus x is going to have to be greater than or equal to 0. Negative x is greater or equal to negative 7. So x is less than or equal to positive 7. What does that look like in interval notation? Yep, negative infinity is 7. Bracket. I'll accept either or. 15. Olivia, what shape does that make if I graph it? It's a line. It's a line with a y-intercept of 5 and a slope of -1. But, Olivia, without a doubt, on the test, people will write this. X can't be 5. Or X greater than or equal to 5. And you could plug in any number, you get an output. 16. Anything. Are you ever going to divide by 0? No. 17. Because can x squared plus 1 ever be 0? No. 18. Uh-oh. Can't take the square root of a. So we have to say that 3 plus 2x minus x squared is greater than or equal to 0. I'm going to multiply through by -1, so x squared minus 2x minus 3 is less than or equal to 0. We just had a test on this, didn't we? Solving nonlinear inequalities. Crosses through -1 and 3. Are we looking for where it's positive or negative? Yep, we're looking for where it's below the x-axis due to our symbol. And so that's going to be from -1 to +3. 19. Can't take the square root of a negative. Look at the graph of x squared plus 2. Is it ever negative? Well, then we would have to solve. So if it's x squared minus 2 equals 0, that would be x squared is equal to 2, or x is equal to plus or minus the root of 2. So you would have those two spots you would set up then. So you would have this shape, a parabola, that went through negative root of 2 and positive root of 2. And you would have to choose the part where it's above the x-axis. 20. Can't take the square root of a negative. Let's look at the graph. -3 minus x squared. Parabola right side up or upside down? Shifted up 3 units or down 3 units? Is this thing ever positive? It's never positive. We have our empty set, that 0 with a line going through it. There's no numbers that work for us. F of x equals the square root of x plus 2 all divided by x minus 3. Oh my goodness. Okay, good. So we got x can equal 3. And what about the top? X has to be greater than or equal to -2. Good. So if you were to graph this and try to, reason these two together, you would plot that -2, you draw your arrow up and over, and then you would plot 3 and put an open circle, right? So these are all the numbers that work. Everything greater than or equal to -2, but not 3. So therefore, we write from -2 to 3, union 3 to infinity. So, for this type of example, you really have to use interval notation. if it was just x can't be 3, but I have to see that you understand what this means. And interval notation would really be necessary there. When I see you do this, I'm not sure that you understand what it truly means, because I could switch it a little bit. Suppose it was a -3. Well, then that doesn't really play into effect there, does it? And so therefore your answer should just be from -2 to infinity, or just that. You shouldn't really even include that. You know what I mean? The last one, cube root. Does cube root cause a problem? No, but it's in the denominator. I can't divide by, what would give me 0 in the denominator? So x can't be 2. What about the numerator? X has to be greater than or equal to, I have a -4, and I have to leave out 2. Yep. Yep. All right. I've got your assignment. You guys did a good job today.